We're going to solve for angles, finding all solutions, not just angles from 0 to 2 pi. We want to first isolate the trig function, so we can add 1 and divide by 2. I'm going to go through this next step pretty fast, so if you don't understand what I'm doing, make sure you see the link in the description below. So that's pi over 6 and 5 pi over 6. That would be our answer if we were solving from 0 to 2 pi, but we're trying to solve for all solutions of x. So if you look at a graph, pi over 6 and 5 pi over 6 would be here. That's when we're at 1/2. But if we're looking at all solutions, we have multiple answers. So it's going to be pi over 6 plus 2 pi. We can add a 2 pi, but we can add it multiple times. So I'm going to add an n, 2 pi any number of times. We can add it twice. We can keep going, and that'll keep giving us more answers. Same with 5 pi over 6 plus 2 pi n. We start with 5 pi over 6 and can keep adding another 2 pi, giving us our other answers. And n can be any integer, so that means you can also work backwards, and it gives you the negative answers as well. So basically, you can solve as if you were solving from 0 to 2 pi and then add plus 2 pi n at the end for your answer. This one is like x plus radical 2 equals negative x if we thought of it with just x's and not trig functions. So we'd want to combine like terms. Same here, we can add sine x to both sides. 1 sine x plus 1 sine x is 2 sine x. And then we could subtract radical 2 to the other side. And we want sine x by itself, so we can divide by 2. We want an angle where y is negative radical 2 over 2. 5 pi over 4, remember plus 2 pi n now, and it also equals 7 pi over 4 plus 2 pi n. This next one is like 2x minus x equals 0. So again, we could combine like terms. 2x minus 1x is 1x. So 2 tan x minus 1 tangent of x is 1 tangent of x. Now that the trig function is isolated, we can solve for the angle where y over x is 0. So that's 0 and pi. We could say 0 plus 2 pi n and pi plus 2 pi n. But if we look at a graph, 0 plus 2 pi n, we're going to keep adding 2 pi and getting those, and then we get pi plus 2 pi n, and we're getting all of those. But really, a more efficient way of saying this would be we could just say 0 plus pi n and go up by pi's, and then you're going to hit each solution that you need. And 0 plus pi n is the same as just pi n. So that would be the most efficient answer, but these are still valid answers as well. Finally, we have a secant. We want to isolate the secant. And that is like secant of x squared. Then we can plus or minus square root both sides. That's what the secant equals, which means the cosine is the reciprocal. So that was 1 over 1. Flip it, you're still going to get 1 over 1. And again, it can be the same thing as last time. We can say just pi n.